Woohoo, we are live. This is Math 40 Elementary Algebra, and this is the section known as 6.8 Applications of Quadratic Equations. Dun, dun, dun. So I have brought my security dinosaur, or, she's really not a dinosaur, my security Godzilla, to hang with me, offers me support. Always surround yourself with friends and family when you're doing word problems, and multiple colors if that helps. And let's see what we can do about solving these problems. Now, what do we know about the problems? Well, we know that these are going to be problems that involve quadratic equations. So there's going to be squareds in this. So for sure, make sure you have your calculator nearby. It'll help you work everything out. So let's get started. So the first one, a rectangular table. Woohoo! You see, I've drawn one. In fact, I haven't drawn one. I've drawn two. Wait till you see why. I'm a mammal that plans ahead. A rectangular table has a width that is 3 times its length and an area of 12 square feet. Notice that this is written feet squared, but you usually pronounce it square feet. What are its dimensions? So in other words, what's the width and the length? First thing is you've got to decide which is the width and which is the length. To be honest, I am not a great artist, so I am personally very forgiving with drawings. I think most of the time the drawings are for you to help you work out what's going on. So I'm not going to worry if your drawings are a little bit wonky, because I know my drawings are often very wonky. However, if I want to be a little bit more precise, I can see that the width is 3 times the length. So that means the width is technically the long one here. That's interesting. And there's the length. Can you write them down the opposite way? Could you put this the width and this length? Yes. It wouldn't be a drawing that's to scale, but that's okay. Again, this is just a drawing that's there to help you. So what do we know? We know the width is 3 times the length. And we know the area equals 12 square feet. Okay, so I know I'm going to try to use just one variable. So I could use W for width and L for length, and I could do a system of equations. You absolutely could. However, with quadratic equation problems, I'm going to recommend that you try not to do a system of equations. Or if you do, talk to me about it and we can talk through some techniques, because sometimes it gets a little bit complicated. However, I do have this wonderful situation here where the width is 3 times the length. And so let's see, if the width, let's say, is W, is equals 3 times the length, that could be 3 times L. Now I've just used 2 variables. So somewhere on the paper, I should say, I'm going to do it right here. Let W equal the width and L equal the length. Remember, that's declaring variables, so I'm making a note to anyone reading my notes. Now, for this one, would people be able to figure it out? Absolutely, but it's always a good idea to leave notes, just in case you're looking at this later. If I've got W equals 3L, I could do something interesting. Where there's a length, I would write L, but where there's a width, instead of writing W, I could write 3L. Does that make sense? My width, which is equal to 3L, is now 3L. Interesting. My area is 12 square feet. So I know that the area of a rectangle is the width times the length, or the length times the width. So the width is, I could write W, but I could also write 3L. 3L. And the length is L. Notice I've got it all in L. Sometimes when you're doing math, does it feel like you're in L? Yeah, I know the feeling. Sorry, bad joke. 3L times L. And over here, what's the area? The area was 12 square feet. Well, wait a minute. I've got 12 equals 3, and if I've got L times L, that's L squared. I could divide both sides by 3. I could get 4 equals L squared. Well, if 4 equals L squared, oh, I've fallen right off the video. Sorry about that. If 4 equals L squared, what is L? Well, L could either be 2 or -2. I don't need the quadratic formula to solve this. I know how to take square roots. So L, if L squared equals 4, that means L has to be 2, the square root. Now, technically, L could be -2. However, could -2 be the dimension of a rectangle? No. Lengths can't be negative. So if this were just a random problem, I'd have to list 2 answers, but it's not. Okay, if the length is 2, then what's the width? Well, if I go up here, I see width is 3 times the length. Okay, and as usual, I've written so much that I have completely run out of room. So I'm going to write my answer. Where am I going to write my answer? That is a good question. I think I'm going to go ahead and write my answer right here. My length is 2. Now remember, when we answer word problems, always look for units. What are the units for this guy? You got it. We're dealing with square feet, so the length is in feet, and the width is in feet. Let me double check. 2 times 6, that equals 12. So my area is 12, yes. And is 6 3 times as much as 2? Yes, it is. So there's my answer. And I'll draw my little squirrely. There's my arrow. What do you guys think? Kind of woohoo? Woohoo? Yay. Okay. Well, I feel pretty confident with that. Let's go ahead and move on to the next one. Ooh, a right triangle. In a right triangle. So here's my right triangle, and I'm going to mark that it's a right triangle by writing the right angle right there. Remember, that means 90 degrees. Right there, 90 degrees. Okay. In a right triangle, the hypotenuse is 8 meters longer than one leg and 1 meter longer than the other leg. Okay, this is a lot. I'm going to say blah, blah, blah. I've got a right triangle. I'm going to remember to myself, okay, right triangles generally are labeled A, B, C. Not always. And you could label it however you like. I'm just going to go A, B, C to be consistent with right triangles that we did in the previous video. And I'm going to say, okay, I'm going to remind myself that this is the hypotenuse. So the hypotenuse is going to be green. The hypotenuse is here. Okay. Now, again, I was doing this in words, so these 2 legs look identical, but they're obviously not supposed to be the same length. So this is a not to scale. So I need to write the magic words, not to scale. Okay, so let's see. The hypotenuse is 8 meters longer than one leg, so one of these guys, and 1 meter longer than the other leg. What are the dimensions of the right triangle? Okay. So the hypotenuse, C, is 8 meters longer than, it doesn't tell me anything, so I'm going to say than A. I'm going to go with A. C is 8 meters longer than A. So I've got an equals, I've got a C, and I've got an A. And what I've got to do is figure out where the 8 goes. So remember, if I'm trying to figure out where to put, so these 2 things equal? They are not, because C is longer than A. They're not equal. So writing C equals A is not true. So I'm going to have to add 8 to one side or the other. Which side is already longer? Well, C is already longer. So to make them equal, I have to do the plus 8 over there. C, the longer one, is A, the shorter one, plus 8. I have to add A plus 8 more to get up to C. Okay. C is 1 meter longer. Oh my goodness, I can't spell. Longer than B. Let's do B. Okay, so I need some sides here. Here's A, is the pink guy. There's A. And then, let's see, for my last one, yellow. Hopefully that's showing up. That shows up in the video. Good. Okay. So again, if I set up my equation, C and B, they're not equal. C is 1 meter longer than B. So to even them up, to make it an equation, I have to put a plus 1 here to get this to be as big as C, because B is little. Okay. Okay. So I've got C equals A plus 8. C equals B plus 1. Okay, so I've got those. And then what else do I have? I have a right triangle. So I have Pythagorean theorem that says A squared plus B squared equals C squared. Now, what I want to do is I want to put something into this so that I only have one variable. So like in the previous problem, we put everything in terms of L. For this one, I've got a mess here. Okay, well, let me show you if you ever get yourself into a mess like this, because I've got C equal to 2 different things, which is just complicated. But what I can do is I can say, C equals A plus 8. I could subtract 8 from both sides, and I could get C minus 8 equals A. So this tells me what A is in terms of C. And I could say C equals B plus 1, subtract 1 from both sides. C minus 1 equals B. Interesting. So this is A related to C. This is B related to C. And then what could I do? Well, I could take this A squared plus B squared equals C squared that I've got right there. And in place of A, the pink side, I could put C minus 8, the quantity squared. Draw a little line there. And then my B is yellow. That's right. And my B, sorry, I got so excited about my B that I forgot I'm substituting. This is a substitution problem. Instead of B squared, I could write C minus 1, the quantity squared. We're using substitution. So we're kind of doing a system of equations, but not officially. Right? I didn't write it out as a system of equations, but this is a system of equations. And then I've got the C squared. So let's stop for a second and look at what we have. I've got A squared plus B squared equals C squared, which is my free equation whenever there's a right triangle. If I know there's a right triangle, then I've got that equation. And then for A, I took these two and I said, let me rewrite the one with A so that I get A equals C minus 8. Let me rewrite the one with B so that I get B equals C minus 1. And then I can take the pink one that represents A, that's C minus 8, because it's 8 shorter than C, and the B one that's 1 shorter than C here for the B. And then What can I do? Well, I can multiply out. I can totally multiply out. So what does that look like? Well, that's a good question. What does it look like? Now, I'm going to do some hardcore multiplication here. So I'm going to bring out my square, my quad rule paper. And I'm going to write these out carefully because this is going to take a lot. Now, at this point, you may still be using FOIL, or you might be using the perfect square formula. You can use either one. If you're using FOIL, you've got first, c times c, so c squared, outer minus 8c, inner minus 8c, last, negative 8 times negative 8. Where are my bats? Negative 8 times negative 8. Two minuses come together to make a plus. So I've got positive 8 times a is 64. So that gives me c squared minus 16c plus 64. Now, those of you who are using the perfect square formula, you went right from here down to here. Okay. If I have c minus 1, the quantity squared, that's c minus 1 times c minus 1. Okay, again, first, c squared minus 1c minus 1c. You know, I just love doing this. I take my two minuses together, negative c, or the opposite of c times the opposite of c, and bam, I get positive. Positive, or sorry. Oh my goodness, someone isn't sleeping. Oh, my bats are upside down. That seems appropriate, doesn't it? Two minuses, negative 1 times negative 1, positive 1. Those of you who are using the perfect square formula, you went straight from here to here. So this is that whole piece. So I've got c squared minus 16c plus 64. That's the pink part right here. And then I've got the yellow part, which is c squared minus 2c plus 1. That's my yellow piece. And then last, over on the other side, being a lot easier, let's be honest, the green piece. Oh, green piece. They're probably whale watching over there on the right side of the equation. I've got c squared. So far, so good. So what did I do? I had this equation with things squared. Then I squared them. Now I'm going to combine like terms over here. I'm going to set this up and I'm going to say, okay, let's see. Let's see. Oh man, I'm hilarious. Minus 16c plus 64 plus c squared minus 2c plus 1 equals c squared. Okay, so I got c squared plus c squared. Over on the left, I've got 2c squared minus 16c minus 2c minus 18c plus 64 plus 1 plus 65, and the whole thing equals c squared. Okay, now I'm going to do something following on with what we were doing back in 6.7. I'm going to subtract c squared from both sides. C squared minus 18c plus 65 equals, remember, if I subtract everything, that's 0. And now I finally have a quadratic formula. After all this work, I finally have either the quadratic formula or factoring. Up to you. Now, as I look at this, I actually, let's see if I see. Oh, I do see the answer. I don't know if you do. So you could use, those of you who know the quadratic formula, you can use that, or we can factor. $65 is, I could multiply what? 5 times 13. Are there any other ways to break it down? I know 5 goes into it. Let me double check. 65 divided by 5 equals 13. Looks like that's the only way to break it down. So minus 5 minus 13. Will that work? Will this factor like this? We got the c squared, and then I got minus 13c minus 5c. Yes, that'll give me the negative 18c, and then negative 5 times negative 13. That'll give me the positive 65. We did it, yay! Okay, then I use the zero property. So either c equals 5 or c equals 13. Now that's weird. I got two answers. And let me tell you, when you're dealing with squares, you get two answers. Now you might say, wait, we only got one answer for the first problem. Well, technically we got two because we got that minus one. We got the positive one and the negative one. Now in this case, we actually didn't get a plus or a minus. We got two separate numbers. So what we're going to have to do is go through and check them. So I got c equals 5 or c equals 13. So let's go back. Let's see, how do I put this so that you guys can see it? Put that up there, and I'll put the picture down here. Let's take a look at our problem again. We've got A, B, C, and we're trying to figure out what the values are. And so, okay, so let's say if c equals 5, then if c equals 5, then A is c minus 8. 5 minus 8. Oh, that's weird. Negative 3. That's really weird. And then B was c minus 1. 5 minus 1 is 4. That's okay. So I've got a 5, negative 3, 4 triangle. That's right there. This one doesn't make any sense. Okay, so C can't be 5. That's not going to work. Okay, what if we tried c equals 13? Okay, so c equals 13. What was A? A is c minus 8. Okay, so that's 13 minus 8, which is 5. And what is B? B is c minus 1. Okay, so that's 13 minus 1. That's 12. Oh, look at that. So I've got a triangle that looks like this. 13 here, 5 here, and 12 here. That's one of those Pythagorean triples if you watched the previous video. Okay, and then what were the units? The units are meters. This is the correct answer right here. Now, for my classes, you could totally give the answer as a picture if you're actually just going to write out the problem. But if you weren't going to write out the problem, you would say the legs are 5 meters and 12 meters, and the hypotenuse is 13 meters. So now, even though this has become a very, very, very long video, I want to address what the heck happened here, because it seems like the math just totally went off the rails, and the answer is no, it didn't. So let's look back at the math we were working with. The math we are working with is squares. Now, what happens when you square a negative number? Like if I take the number negative 3 and I square it, negative 3 times negative 3 becomes positive 9. Positive 3 times positive 3 also becomes positive 9. So when you're working with squares, something interesting that happens is the math kind of forgets the positives versus the negatives. Plus, when I write out an equation like this, the math doesn't know we're talking about a triangle. The math is just working out the math. It's just a pattern. And so this answer was correct. If we take negative 3 times negative 3, we get 9. 4 times 4 is 16. 9 plus 16 is 25, which gives us the square of 5. So that works. The equation works. The problem is this isn't actually a triangle. So this is a pattern that works, that satisfies all of our requirements, but isn't actually helpful in a physical sense. If I similarly said, I need to solve a problem because I cannot reach the top. It's true. I cannot reach the top shelf at the store. Well, I got two options. One is I bring a little step stool with me and then I can reach the top shelf. Or I could bring a giraffe with me and train the giraffe to get me stuff off the top shelf. Now, a trained giraffe would be really, really cool. And now I'm regretting that I don't have a giraffe puppet. But it would not be practical. Same thing here. You can come up with, in math, you can come up with patterns that will fit, but they aren't going to be helpful. As much as I can't have a giraffe, which now I'm very sad about the giraffe. Okay, before I get too sad about the giraffe, let's do one more problem. This one is going to be so much more straightforward. And in fact, I believe you will probably solve this in your head before I even read it to you, but let's go through it. The product of two consecutive integers is 20. So the first thing we got to talk about is what the heck does consecutive integers? Consecutive integers are integers that are next to each other. So an example, I could pick 11 and then 12, or I could pick 6 and then 7, or 103,000 and then 103,001. So they come right after each other. That's what consecutive integers are. And so I want two consecutive integers whose product is 20. And I know if I were doing this in class, people would be yelling, it's 4 times 5, it's 4 times 5. And the answer is yes. But sometimes when we do word problems, it's not the question of can we get the answer? It's actually a question of, because a lot of times answering the question is pretty straightforward. It's can we set up the equations? Because this is the practice that's going to get us set up for when calculus happens and the answers are not so obvious. So we practice making the equations. So this is all about the question, not the answer. So if I have consecutive integer, this is the way I look at it. You can also read the book. They have a slightly different way of looking at it. First integer. And I've always used the letter n for number. So I'm going to say the first integer is n. Then I need to figure out what the second integer is. Now, if I look at 11, 12, 6, 7, 103,000, 103,001, I see there's something pretty consistent. Every time I go to the next one, I take the previous one and I just add 1 to it. So my first integer is n, my second integer is n plus 1. And this is how we're going to do consecutive integer problems. Okay, and it says the product equals 20. So now what's the product? The product is multiplied. So I've got n times n plus 1 equals 20. Notice I have to use parentheses around the n plus 1. I didn't have to do it around the n. I just did it because it felt parallel in some way. But n plus 1 has to be in parentheses because you got to keep the whole number together. Okay, well, that's exciting. Can I multiply the left side? Sure, I can. That's just n times the quantity n plus 1. So that's n squared plus n equals 20. Now, what can I do? Well, if I'm solving a quadratic equation, I subtract 20 from both sides. I know I'm doing this, and as I'm doing this, you're all like, the answer is 4 times 5. Please, just 4 times 5. Yes, yes, this problem is actually easier than the solution. But again, this is good practice. I have seen what's coming, and I just want to tell you, you will be so much happier having done this practice. So as annoying as this is right now, and as how obvious, and just even Godzilla's like, come on, why are we doing this? We should be eating donuts. Whoa, I just had a thought. What if we started eating donuts during the videos. You could do that. I can't. I would spit donut everywhere. It would get awkward. Okay, back to the math. N squared plus n minus 20. This is really worth it, even though right now I know everyone's like, oh my gosh. N squared plus n minus 20 equals 0. We need to factor this one. So you can use, what can you use? You can use trial and error. You can use the AC test method. You can use the magical X method if you know that one. There are a couple of other ones. There's like a lattice method and I'm sure there's a platypus method. If there isn't, we need to invent it. But I'm going to use good old trial and error because that's what I'm used to. N squared breaks down into n times n. Then I need two numbers that multiply to negative 20. I could do -1 and -20, or -1 and 20. I could do -2 and 10. I could do -4 and 5. Ooh, how about -4 and +5? Does that work? Let's double check. I get a plus n in the middle, -4n plus 5n. Yes, that's going to work. Okay, so n minus 4 equals 0, or n plus 5 equals 0. That's the 0 property. +4 plus 4, n equals 4, or, and again, why is math messing with us? What, does math hate us? And the answer is no. Math loves you, truly. Math loves everyone. It's just misunderstood. It has a language all its own. And so it's trying to help you. And we have to say, I'm sorry, math, that's not what I was looking for. Again, that's like that giraffe solution. It is a solution. If I were to bring a giraffe into stores, it could knock things off of the top shelf for me to reach it, but it's not practical. And I'm guessing that Target would get cranky if I tried to bring a live giraffe into their store. So could n be -5? No. Why not? What are we looking for? We're looking for integers. -5 is not an integer. So it's right out. So we say it's not that one. See how this works? Sometimes we get two answers, sometimes we just get one. I'm going to tell you a terrible story. It's a very short, terrible story. Sometimes when you do these problems, not now, but later on, you know, like more algebra after this, sometimes both answers don't work. Like there's no answers. You'll get two answers, you try them both, neither of them works. I know, it's so frustrating. Sometimes it's like, okay. But what if n equals 4? Then what's the other number? The first integer is n. The second integer is n plus 1. Oh my goodness! The answers are 4 and 5. I know, you already knew this. Thank you guys for making it through with me. You guys are amazing and incredible. Remember, don't spend more than half an hour in any given word problem. If a problem is giving you a hard time, talk to me, talk to a tutor, talk to your friends, strike up conversations with perfect strangers. You never know, they might know math. And, you know, just don't burn out. Don't hit your head against a wall. Ask for help. It takes a while, but this is, I'm telling you, this is really worth the practice. It's like working out, but for your brain. Woohoo! Your brain could be all swole. Well, no, that's encephalitis. You don't want that, but you know what I mean. Anyway, okay, before I get too silly, Godzilla says, bye. Good luck with your word problems and your homework. You guys are awesome. Woohoo. Math on. Woohoo!